Okay, before we start with today's lesson, I want to give you 2 keys for success for your team. Number 1, look out for your teammates, right? Make sure that when your teammates walk away from this lesson today, they not only have correct answers and have complete work, but they also have complete understanding of what's going on. Number 2, while the video is going, please make sure to stop and answer and ask questions. So whether it's a question that's asked of you by me in the video, or it's a question that your teammate has because they're a little bit confused, stop the video to ask and answer questions. Those are the 2 key things that I think if you really focus in on today, you guys will get a lot more out of your group. So let's go ahead and look at the do now. The do now is just basically finding the areas of some basic figures. So at this point we've talked about finding basic areas of rectangular figures, triangular figures, and figures that are portions of or complete circles. So this first one is the area of a rectangle. We know that the area of a rectangle is equal to base times height. So when we're looking at today's lesson, one thing that's going to be important is making sure that you correctly identify and write down the equation. So the equation here, base times height, 10 times 3 is equal to 30. Focus in on here and notice that we're using the same 3 steps as we go through our work. We write an equation, we plug information into the equation, and we solve the equation. Those 3 steps are going to be crucial for you throughout the entire year. Write the equation, plug in the equation, solve the equation. Coming down here, we have what is the area of the figure below. So the figure below is a triangle. Our equation for the area of a triangle is 1/2 of the base times the height. So I'm going to write the equation. I'm going to plug my values into the equation. Then I'm going to solve the equation. Half of 10 is 5 times 3 is going to give me 15 meters squared. So again, write the equation, plug into the equation, solve the equation. Moving over here, we have what is the area of the figure below. So here we have a circle. So our equation for the area of a circle is equal to pi times radius squared. So again, I've written the equation. Now I'm going to plug the information I know into the equation. So that's 3 squared. 3 squared is 3 times 3, which is 9. So the area of this circle is 9 times pi. D. Again, we can see, write the equation, plug into the equation, solve the equation. Finally, we have one last, is what is the area of this figure below. So we know that the area of a circle is equal to pi times r squared. So the area of half of a circle is going to be equal to 1/2 of pi times r squared. So I've written an equation. So this area is going to be equal to half of pi r squared. Now I'm going to plug into the equation. Now looking here, I've been given the diameter, and so I know that if the diameter is 10, I can't plug that in for r because it's not the same thing, but I can identify that the radius is half of the diameter, which would be 5 squared. So I get half of 5 squared, which is going to give me half of 25 pi. So the area would actually be 12.5 pi. So we can see our answer here is none of the above. Alright, so those are some of the key shapes that we need to find the area of to get into our work for today. Today's aim, Kipsters will be able to find the area of composite figures. Find the area of composite figures. So when we talk about composite figures, we're talking about figures that are made up of more than one shape or may have a larger shape where something has been taken out of it. So for example, let's start with our first composite shape. We're looking for the area of just the shaded region. And so the question I'm going to be asking myself when I run into all of these composite figures is, am I adding shapes together or am I subtracting shapes? So in this particular problem, I see that I have a circle, a large circle, and what seems to have been taken out of it is this center circle. So I could represent this as the area of this entire figure. So I'm going to say area of C for my composite figure would be the area of the large circle minus the area of the small circle. So I had the large circle and then somebody took out the small circle. So my area for my large circle, there are a couple different ways we can do this. I'm going to do the areas independently. The area of the large circle is equal to pi times its radius squared. So for the area of the large circle, it's going to go from the radius all the way out here. And so I count that the radius is 1, 2, 3 units. So this is going to be pi times 3 squared. So the area of the large circle is 9 pi. I can write that into my equation, 9 pi. The area of the small circle is what was taken out on the inside, and so I'm going to use the same equation for the area of a circle, pi times radius squared. This time the radius of the small circle that was taken out is 2 squared. That's going to give me the area of the small circle is 4 pi. I'm going to plug that back into my original expression that I had to find the area of the composite figure. That gives me 4 pi. So this is going to be 9 pi minus 4 pi is 5 pi. And then it asks me to use 3.14 for pi. So I'm going to go ahead and plug that in. 5 times 3.14. And that's going to give me 15.7. And then we don't have units, so we'll call them square units. So what we can see today is today's going to be a lot of puzzles. You're going to be identifying, hey, how can I use the pieces that I have here to either put figures together to add up to something or take figures away from something that's larger. So let's start with this particular figure. It says that the yard is shown with the section indicating the grassy areas of the unshaded sections indicating the paved areas. Find the area of the space covered with grass. So the grassy areas are the shaded regions. So when I look over at this shaded region, I need to ask myself, is this shaded region something that's a bunch of pieces that we've put together, or is it something that was larger and had something taken away? Discuss within your group what this could be, whether it's figures put together or it's taken away, and if you've decided what the figures are that put together, write an expression for the different areas that you need to add together, or if you think it's something that's taken away, write an expression to represent what's been taken away. So you should have paused the video to have that discussion about the particular shape here. When we recognize this particular shape, we see that it is a rectangle that has a rectangle taken out of it. So the expression that I should be writing is our area here. I'm going to say area S for area for shaded is equal to the area of the large rectangle minus the area of the, this is where I'm going to run in, I'm going to call this SH for shaded, and I'm going to call this SM for small. Alright, so the area of the shaded region would be the area of this large rectangle minus the area of this small rectangle. And I'm going to label this on my, here is the area of the small, just so I don't get confused. Alright, so I need to find the areas of these two shapes in order to find this. So the area of my large rectangle, it's a rectangle, so I'm using the equation base times height. And we need to identify the length or the base and the height of this rectangle. So I count it out. I count 1, 2, 3 units, and I count 1, 2 units tall. So my area is going to be equal to 3 times 2. That's going to give me 6 square units. This is the area of my large shape, which I'm starting with before I take it away. Now I see that something is taken away here, and it's the area of the small shape. Now, the interesting thing about the area of this small shape is that it doesn't give me anything directly on a grid line, so I'm going to have to estimate the base and height here. So when I look at this base, I see that it's definitely not a full unit wide, and it looks like it goes from about a quarter of the way to a quarter of the way in, and so maybe this looks like in total this is about half of a unit wide. So I'm going to say the base of my shape here is 0.5 or half of a unit. And when I look how tall it is, this definitely looks like it's almost exactly 1 unit tall. So my base times my height is going to give me 0.5 times 1 or 0.5 square units. Or 0.5 square units. So again, this is subtraction because we had a larger area and we took a smaller area out of it. So 6 minus 0.5 is going to give me 5.5 square units. Alright, let's come over to the next one. Now looking at this next shape, we want to find the area of the figure that consists of a rectangle with a semicircle on top. So the question we ask ourselves here is this multiple shapes that have been put together, or was this a larger shape with something taken out of it? Discuss with your group whether this is a shape that is multiple put together, or if it was something that was larger and taken away. If it was something that was larger and taken away, write a subtraction expression to represent the area. If it's something where it's put together, write an addition to represent the areas that have been put together. So as we read this problem, it tells us that this is actually a rectangle with a semicircle on top. That's a key to tell us here that we're looking at a shape here that is a rectangle with a semicircle on top. So looking at this, we know that this is a semicircle with a radius here. So we can write our expression here that our area is equal to the area of the rectangle plus the area of the semicircle. I'll just call that area S. To continue from here, now we need to find the area of the rectangle and the area of the semicircle. So the area of our rectangle is going to be equal to base times height. So it's obvious to me when I look at my rectangle that I can see that the base is 4, but the height is unknown. The 7.5 goes all the way to the top. So I'm going to have to figure out some other way to do that. I'm going to move on for a second to look at the semicircle. The area of the semicircle is going to be equal to half of pi times radius squared because it's half of a circle. I think the biggest mistake here is that people tend to forget that this is half of a circle, so they don't put the half times the pi r squared. Now when we look at this particular circle, we can see that our diameter here would be 4 meters because it's the opposite side of this rectangle, which means that our radius is going to be equal to 2. our radius is going to be equal to 2. So for this, we have 1/2 times pi times 2 squared. And it actually tells me to use 3.14 for pi, so I'll go ahead and replace that with 3.14 here as my estimate. 3.14. Sorry, that's kind of sloppy. Alright, so when I do that, I should be able to do that multiplication. Check it with your calculator. 1/2 times 2 squared would be 1/2 times 4, which would be 2, times 3.14, which would be 6.28 meters squared. Now, having gone through all of that, that actually gives me some ideas when I start to look at my height over here. When I look at my height, I now know that the semicircle is 2 units tall. And so if I take out that 2 units, that tells me the rest of the rectangle is 5.5 meters tall. So now my height is 5.5. That gives me 4 times 5.5 is 22. So my area of my rectangle plus the area of my semicircle would be my whole thing. The rectangle is 22 plus 6.28, which would be equal to 28.28 meters squared. Let's come down to one last problem. This is one that I think you should be able to do on your own. It asks you to find the area of the shaded region and using 3.14 for pi. So to begin this, ask yourselves and your team, am I putting shapes together or am I having a larger shape where something is taken away? Go ahead and answer that question for yourself and then write an equation in terms of the areas of the shapes that would help you find the area of the composite figure. At this point, you should have identified with your team that this is a composite figure where the total area, or the composite area, would be the area of a triangle plus the area of a semicircle. This is the basic equation that you should have written. Then you want to come down and go ahead and write your individual equations for the area of a triangle and the area of a semicircle. Do that on your own before the video continues. So the area of the triangle would be 1/2 of base times height. The area of the semicircle, again, its full circle would be pi times radius squared, but it's half of a circle, so I want 1/2 of pi r squared. So looking through this, now we need to identify the base and height of the triangle and the semicircle. So the radius should be pretty easy to find for the semicircle. The base and height of the triangle may be a little bit trickier. See if you can determine with your teammate all 3 of those values and plug them in. Pause the video until you've come to a conclusion. If you get stuck on one of the values, go ahead and restart the video in order to get a hint. So looking at the radius, we can see that the radius would just be the same thing as the height of the circle, which you should have written into your equation. 1/2 of pi times our radius here is 4 squared. I'm using pi as 3.14, so I'll plug that in. And this is 4 squared. Now, looking over at the triangle, this is where things get a little bit tricky. 1/2 of the base is clearly 14. The height requires a little bit of tricky thought. So looking at the height here, the height of this is really just the diameter of the circle. Well, we saw that the radius was 4, which means the diameter would be 8. If your teammates don't understand where that diameter of 8 come from, please pause the video and explain to them now. Alright, let's move on to the other side. As soon as we do some calculations here, area of our triangle would be 1/2 of 14, which is 7 times 8 is 56 centimeters squared. The area of our semicircle would be 1/2 of 4 squared, So 4 squared is 16 times 1/2 would be 8 times 3.14, which is equal to 25.12 centimeters squared. So if I come back, I originally said that the area of this composite figure was the area of the triangle, which we've now said was 56 centimeters squared, and the area of the semicircle, which we've now said is 25.12 centimeters squared. Add that together, we're going to get 81.12 centimeters squared. Flip on over and let's go ahead and move on with a couple more problems. Alright, so looking at this one, this has to define the area of the shaded region. So once again, discuss with your teammates, is this something where we have taken away from a larger shape, or have we put together some composite pieces to make one larger shape? You and your teammates should agree that at this point we recognize that this is a larger shape where smaller shapes have been taken away. In order to do this, I want you to ask yourself and your team, go ahead and write an equation to represent the area of the shaded region in terms of the areas of the shapes that you can find. If you need a hint, ask yourself, what is the largest shape and what shapes were taken away? The equation that you and your team should have written was that the area of the shape is equal to the area of the square, or the area of the rectangle, minus the area of triangle 1, minus the area of triangle 2, minus the area of triangle 3. I recognize here that this is one triangle, two triangles, and three triangles that were taken away. In order to find the shape, the area of this shaded area, I'm going to need to find the area of 4 different things. I'll go ahead and do that work down here. Go ahead and work with your teammates to find the area of all 4 of these individual shapes. The hardest part may be identifying the base and height for all of the different shapes. Try and figure out and label all of that all on your own. If you need support, that's the first piece that I'll be doing as I move forward with this video. So again, you and your teammates should be working on your own to identify the base and height of all of these pieces, but part of the work is to see something that's a little bit more complicated and use your puzzling or your problem-solving skills to figure it out. Those are the things that are really going to push you forward. So looking at this, I'm going to start with triangle 1. I can clearly see that one of the base or height is going to be 20, and on the other side, it's not going all the way down. I can see that it's cutting off 6 centimeters from the bottom. Well, if it was 20 all the way to the bottom, and I've cut 6 centimeters off of that, that tells me that 14 centimeters should be our height of this triangle. For triangle 2, both pieces are clearly labeled 6 centimeters and 8 centimeters. Looking at triangle 3, if you hadn't figured out triangle 3 already, use the same idea that we used for triangle 1 to help determine the other side of triangle 3. You and your teammates should recognize that the total length of this side is 20 centimeters, and for this triangle, 8 of those centimeters have been cut off. Here we have 12 centimeters as our missing side for this. Now that we have the base and height for all of our triangles and our original rectangle, we should be able to write down and fill in and solve all of our equations. Go ahead and work with your team to find all of the areas of the individual pieces that are here. Return to the video to check. Alright, having found all of the areas of the individual pieces, the area of the rectangle, I've seen the work here, is that the area of the rectangle is 400. The area of the first triangle, 1/2 base times height, is 140. The area of the second triangle is 24, and the area of the third triangle is 120. Notice the organization of my work that allows me to go from the figure where I've identified the different triangles and labeled them on my paper, where I've also labeled the lengths or the bases and the heights of the triangles, so I know where that comes from in my equations, and then I've found each of the areas that I'm now going to plug into the original equation that we wrote. We started with the area of the rectangle, which was 400. We subtracted away the area of the first triangle, which was 140. We subtracted away the area of the second triangle, which was 24, and we subtracted away the area of the last triangle, which was 120. Going ahead and combining all of this, these are all of my subtractions. This is going to be equal to 400 minus 288, minus 400 minus 288, which will leave me with 212 centimeters squared. Now, if you worked through this problem and you did most of your work waiting for me to do it, you missed out on a huge opportunity to do the problem solving yourself. You will see problems like this on tests, on quizzes, or this is more of the problem solving that you need in the real world. Coming over to this last one, it says find the area of the shaded region. The figure is not drawn to scale. So again, you need to ask yourself, did we have larger areas where something was taken away, or did we have an area of different pieces that we've added together? For this particular problem, I know when I first looked at it, I struggled to figure out what it was. Use this hint that maybe the larger area we started with is the combined area of two figures. See if you can't write an equation to represent the different pieces and how they interact to give us the area of the shaded region. I see that they've labeled the area of the shaded region as G, so as I write my equation, I'm going to say that area G is equal to, and now I need to figure out how I can do this. So I've got an area of a large rectangle, or I've got the area of two rectangles. That seems to be what I've started with, and then I can see that I've taken away this triangle, and this is where I struggled the first time, was to see this triangle all the way through here. So if we think about this as two rectangles that were put together, and then two triangles that were taken away, if you haven't already written an equation that would seem to look like that, go ahead and do that now. Your equation should look like something along the lines of the area of rectangle 1, I'll call this rectangle 1, plus the area of rectangle 2, we'll call this one rectangle 2, and then we took away these two triangles that I have labeled here in red. So we'll call this triangle 3, just so I don't get it confused with the numbers from my rectangles. And this triangle all the way through here, I'll call triangle 4. And those were areas that were taken away, so I'll represent those with subtractions. Alright, now we need to go through and find the area of each of these individual pieces. The area of rectangle 1 would be a base times height, The area of rectangle 2 would be a base times height. The area of triangle 3 would be a 1/2 base times height. And the area of triangle 4 would be a 1/2 base times height. Finish this problem with your teammates, finding the areas of the individual pieces and then using them to find the area of the remaining shaded region. Returning to this, I see my rectangle 1 has a base of 3 and a height of 3. So that gives me a base times height of 3 times 3, which is 9. The area of rectangle 2, I can see has a base and a height of 2. So the area is going to be equal to 2 times 2, which is 4. Looking at my area of my third triangle, my triangle 3, I can see that it has a base that's the same as the rest of this rectangle, so this is going to be 3 centimeters, and a height also of 3 centimeters. So this is going to be 1/2 of 3 times 3. Put into my calculator, should have given you 4.5. The area of the fourth figure is equal to 1/2 of base times height of this fourth triangle, which is this large triangle that actually goes through both of the shapes. And I can see that the height of the triangle is 2, and the base is 2 plus 3, which would make the base of this triangle 5. So 1/2 of 5 times 2, that would be half of 10, which is going to be 5. So coming back, we started with the area of the two rectangles put together. So rectangle 1 was 9 plus 4. So we started with 13, and then we subtracted away the smaller triangle over here on the right side, triangle 3, which we said was 4.5, and the slightly larger triangle over here on the left-hand side, which we said the area was 4. That gives us a total subtraction of 8.5, which would give us a total area remaining of 4.5 centimeters squared. So as you can see, a lot of this is all about puzzling. It's about finding the pieces, figuring out how the pieces fit together. Is it a subtraction or is it an addition? Identifying first this relationship with this equation to find what you're looking for is the most important piece, as finding the individual areas thereafter is relatively easy. Let's flip on over to the alone time and just get you a quick start and a couple quick reminders there. As we look at our alone time problem, again, the first thing you should be thinking about is, am I looking at a bunch of pieces that were put together for the shaded region, or is the shaded region what remains after something was taken away from a larger shape? First, identify with an equation that relationship between the different pieces here, and then go ahead and find the individual pieces and plug in to find the shaded region. Work on this independently, and then when you're done working on this independently, go ahead and move on to getting some work done on Khan.